So this is where we stopped last Thursday. In the last problem is this here, which is how to use your calculator to find the standard deviation and the variance. So if you remember, I told you guys that in your calculator, when you do the 1-volt stat, your calculator can only give you the standard deviation. Your output in your calculator only give you the standard deviation. To find the standard deviation, you need to take the, to find the variance, you need to take the standard deviation and square them. So if you look at this thing here, which is, if you have the calculator, just go back to do the first problem. For those of you who did not have a calculator earlier or last time, but again, to work on this problem, to find the range is easy. The range is the highest minus the lowest, which is your range. And to find the standard deviation or your variance, the first thing we need to do is you need to hit on stat, which is again this item here. You hit on stat and you need to edit your data. Reminder, if you have some data, like this thing here, and you want to clear this data, make sure that don't delete. You have to go to L1 and hit clear. If you hit clear, they will clear the whole item. If you hit delete, and again, I just want to show you guys, if you hit delete, everybody see that my L1 disappear. If you hit delete, you delete the whole thing. And if you happen, whoever did happen to delete your item, this is what you need to do, is you need to hit stat and go to the setup editor, which is again, setup editor number 5, hit enter and enter again. You have to do that in order for you to get your L1 back. So everybody see that I delete my L1 and now I got my L1 back. Okay, so make sure you have L1, L2, L3 to keep it in sync with my item. But again, we did this problem last time, which is you type in your data, which is 16, 6, 18, 3, 25, 22. So once you type in this data, just make sure that you type in the correct data. The reason is on your test and on your quiz and everything you do is a lot of calculator dependent. So make sure double check or triple check your data, because if you have a wrong number here, your output will be wrong. So again, I have 16, 6, 18, 3, 25, 22. So I have my data. I have the 6 data that I needed right here. I put it here. And once you have this thing here, you hit stat again, and we move to our calculation. Instead of edit, we go to calculate, and then we use the 1-volt stat, which is you choose the 1-volt stat. And again, this is my 84. So if you have 84, you probably have this window prompt, which is your list is L1. Leave the frequency by itself blank, and you just go to calculate. If you have 83, you just press enter, and they will give you this output. So this output is what we have. And make sure, like I mentioned to you guys on the screen here, make sure you know which one is your sample and which one is your population. The tedious item that a lot of students frustrate with themselves is they put in the wrong answer for the wrong question. This one here, they ask you for the sample variance. So the sample variance, we have to use the sample standard deviation to find the sample variance. So this is your sample, which is your S. Your S is your sample, and your sigma is your population. So this problem over here, they ask you for the sample. This problem over here, they ask you for the population. So make sure that you know which one they ask you so that you're using the right number. So we have this. This is our standard deviation, which is, as you can see, my standard deviation, which is the S, and my standard deviation is 8.8. Okay. And like I mentioned earlier, calculator only give you the standard deviation. How do we find the variance? Well, you take the standard deviation and you square them. So to do this thing here, 76356, you have to use this item, which is 8.76356 square. You need to take this standard deviation and square them. And if you square them, and the reason why I use a lot of decimal is make sure, ladies and gentlemen, please do not do this on your homework or on your quiz, on your test. Do not use 8.8 square. The reason is if you use 8.8, you estimate this number a little bit bigger. And when you estimate this number a little bit bigger, your answer will come out a lot bigger because, again, you make your bigger item already. So make sure that looking at this thing here, we use at least 5 decimal places. Like I mentioned, if I did not mention on Thursday, make sure that in your process, don't round your answer in your process. You only round the answer at the last step as your answer, okay? So looking at this thing here, when you take this number and square, you have 76.799 this item we have. And again, your final answer will be 76.8. So reminder, the rule of rounding, unless Connect Math tell you how many decimal they want it, if they don't tell you, they don't ask you, then you have to give them 1 extra decimal than your data. Since your data have all whole number, you give them 1 extra decimal. But you don't round your answer until your final result. Okay, as you can see on my calculator, if you use 8.8, the answer will be wrong because it's too big, because you estimate them and then you use the estimate to estimate another one, which is it will be very big. Your Connect Math will tell you it's wrong. But go back to this question, any question in terms of how to find your standard deviation or how to find your variance? Any questions so far? And ladies and gentlemen, your standard deviation will always be smaller than your variance. Okay, if you saw the question on your homework and they ask you for both variance and standard deviation, make sure you know your notation, or make sure that if they ask you for variance, your variance is always bigger than your standard deviation, because the variance, to get the variance, you need to take the standard deviation square. Okay, so to finish this, to do B, if you look at B again, similarly, we need to enter in our data. And if I have this data and I want to clear, and I don't want to clear one by one, I need to go to select L1 and hit clear. And then press enter, my L1 is clear. Okay, do not press delete. And again, all you do is you type in your data, which is 28, 11, 23, 27, 29, 62, and 4. So hopefully, double check your answer. Make sure you have 8 data, which is in this case, I have 8 data, and make sure you type in the right number. And that's the one thing that a lot of students make mistake on the test, on the quiz, is they type in the wrong number. But again, 4, 63, 62, 29, 27, 23, 11, and 8, and 20. So I got the answer, I got my data. And again, reminder, you hit stat, you go to calculate, and we're using 1 var stat. For now, we're only using 1 var stat. We're not using anything else. And then just go to calculate, and hopefully we have the same output as we have here, which is, everybody see that 23 is my mean. My sample standard deviation is 18.17376, and my population standard deviation is 17. So make sure which question are they asking me, and that's the challenge that you have to overcome and ask yourself, which one are they asking me? Because they ask me population, or because I have my data as in a population data, I have to use the population standard deviation and not the sample. Everybody see that here. And that's the challenge that you need to overcome. Do not be careless and just using any number you have. Make sure that if your problem deal with population, you use your population notation. If your data is deal with sample, you use your sample notation. So first of all, as you can see, we have this, which is my standard deviation. To find my variance, I just need to take the standard deviation square, which is all we need to do is take the 17 times 17, right? 17 squared is 17 times 17, which is 289. Or if you later on, you will see that the caret sign is the same, which is you can say 17 caret 2, which is 17 square. So it doesn't matter how you type in, the variance is 289. So question with this A or B, which is this problem, I believe we did it last Thursday, A, and today we do B. So question on how to find the variance, how to find your standard deviation, or how to use your calculator.
I had a quick question.
Go ahead.
When you go to stat, because I was having problems on 3.1 homework, it wasn't, the numbers weren't coordinating with like the ones that they had on Connect, I think it was. And when you click var stat and it says list 1 frequent list, is that supposed to have anything in there?
If remember, the only time you use your frequent list if you have a frequency distribution. If they ask you approximate the mean, and they have your data, which is you have to find your midpoint, and then you have a frequency, which how many often they have. If you have L2, then that is your frequency list, right? That's your question, right? Your frequency list right here, most often the only time you use your frequency list is when you have your L2, which is you have your data in L2. If you don't have your data in L2, then you don't use your frequency list. Your frequency list, because I don't have any data in L2, I leave my frequency alone. My frequency list would be blank.
Okay, because I think I put, it was L1 in there for some reason, and I think that's why it was messing it up.
Yeah, if you have the L1, your frequency list, you leave it blank. The only time you use your frequency list if you have some data in L2, and then you go down here and you say my L2 is my frequency. You never put L1 here because your L1 is your data already. You don't list your data as a list again. So the only time you use your frequency list is you have some other data, which is L2.
Okay, thank you.
All right. So any other question here? All right, if you don't have question, let's take a look at the next item we have, which is a little bit. If you came from 120, you already know this item here, which is the last thing in 3.2 is we have this data and we want to know how much data will be contained within the interval that we have, okay? So the first thing we have is if we have a symmetric, a histogram, if they are symmetric, we call this thing here like a bell-shaped curve. And the bell-shaped curve is very unique in the sense that the mean is in the middle. And when we get to chapter 6, 7, and 8, when we say this a normal bell-shaped curve or normal distribution, the unique thing is the mean, the median, and the mode is at one location, which is in the middle. But for now, this is our bell-shaped curve. And the reason why we introduce the bell-shaped curve is we have this empirical rule. And the empirical rule, as you will see, or as some of you already saw, the empirical rule just tell you this. If my middle number is the mean, they say within one standard deviation. The reason why they say within one standard deviation, meaning if we take one step above and one step below, if we take one step above and one step below, that will consider 68% of my data. Meaning again, between these two numbers, between this number, whatever this number is, and whatever this number is, will include 68% of my data. For instance, to put in the numbers perspective, for instance, if I have 100 students, and whatever the grade is, whatever the average is, within one standard deviation, 68 students out of 100 students that I have will be between this grade and this point. Whatever this point, the lower point, and whatever the upper point is, that will be 68% of my data. And as you can see, the bell-shaped curve, the highest peak is in the middle, which is that's where your mean is at. And the further away, it starts to get decrease, which is basically the area or the percentage is the area underneath this curve. The higher the peak, the bigger the area, and the further away from the mean, the lower this thing drop. And the lower this thing drop, the area underneath will be a little bit less, and less. Okay, so the idea of this empirical rule here is always fixed. Why is always fixed? Because if it's a bell-shaped curve, it's always have the same symmetrical bell-shaped curve. And if it's the same symmetrical bell-shaped curve, within one standard deviation, it will cover 68%. Within two standard deviation, it will cover 95% of my data, which is, as you can see, from this point, whatever this value is, and later on you will see that your goal is to find this value, whatever this value is between these two values, that will cover 95% of your data, okay? So within two standard deviation, and as you can see, this is what I tell a lot of my students is, when they say within, think in terms of you taking the steps. Within, meaning you take 2 steps above and 2 steps below. Whatever step you take, the actual unit, that is your standard deviation, okay? And we will see an example, and hopefully you will see a little bit easier in detail. And lastly, if you came from the other class, you would say, wait a minute, the other class tell me it's 99.7. Yes, it's 99.7. Later on, they will say it's 99.7. But for now, in chapter 3, if we take 3 standard deviation above, meaning you walk 3 steps above and 3 steps below, that will include almost all of your data. Meaning whatever this unit, whatever this point, and whatever this point is, will include almost all of your data. There will always be an outlier, which is next section, you will see the outlier, and there are some extreme number and there are some extreme high and extreme low, which is we never include all of our data. We can only include almost all, which is 99.7, okay? But for now, just almost all. And on Connect Math, they ask you almost all. So this is your empirical rule, and it's a fixed number, ladies and gentlemen. The empirical rule is a fixed number. It just tells you that within one standard deviation, meaning you go above 1 and below 1, 68%. Above 2, below 2, 95%. Above 3, below 3, almost all of your data, okay? So we using this empirical rule, we're using this item to analyze, to answer our question. So looking at this question here, or looking at the next slide, they give us this information. They give us the following data is a population, which is, we have the mu equal to 18, which is the mu is the mean which is in the middle. And the standard deviation is sigma equal to 9. they ask you that assume that the population is a bell shape, and make sure when you read the question, make sure that you see this item here. Make sure that you see that it's a bell shape. If it's not a bell-shaped curve, if it's not a normally distributed, then we cannot use this empirical probability or empirical rule. The empirical rule only work with a bell-shaped curve. Okay, so make sure when you read, and that's your challenge, is you have to identify which kind of question that you have. So in this case, we have a bell-shaped curve. So we know the bell-shaped curve, we know that we can use my empirical rule. Okay, and now they ask you between what two value? Between what two value will approximately 68%, which is, do you agree that 68% is right here, which is between this value and this value? Which is now, if you see this, we can plug in the formula. We have the two items, right? They tell you to find this number, which is the mean minus the standard deviation. So I have the mean, which is 18, the standard deviation, which is 9. So I know that 18 minus 9, I can say that this is 9. And this value, 18 plus 9, which is 18 plus 9, to give me 27. So the idea of this empirical rule is, if we have the mean and if we have the standard deviation, we know that within one standard deviation, meaning you take one step. When you take one step, the actual unit that you need to add in is 9. Okay, so when they say within, think in terms within, meaning how many steps we need to take, which is within one standard deviation, we take one step above, one step below. So in the same way, if you want to, this is your formula, right? Your mu 3 times sigma, meaning you take 3 steps, 2 times sigma, meaning you take 2 steps, sigma, meaning you take 1 step. So everybody see how I got 9 and 27. They ask you between what two value. I know that this is the lower endpoint, which is 9, and this is the upper endpoint, which is 27. So between 9 and 27, it will cover 68% of my data. Question of how I got this 9 and this 27. Now, to be in short, to make it easy, just think in terms that this is your formula. Your goal is you plug in your unknown, which is they give it to you right here. They give us wrong item. They give us the two things that we needed. They give us the mu and they give us the sigma, which is, those are the two things we need. And similarly, they can switch, they can switch the script, right? Instead of ask you the value that cover, instead of ask you the value that cover 68%, they can ask you, well, if I have the value, what will be the percentage that is covered? So they ask you, assume that the population is a bell-shaped curve, which is, as I mentioned, they tell you that it's a bell-shaped curve, meaning it's symmetric. Then we can use your empirical rule. Approximately what percentage of the population is between -9 and 45? So looking at this thing here, you ask yourself, well, in the middle is 19. That is where my mean is at. My mean is 19. How many steps can I get from 18 to 45, right? Or basically you can take 45 minus 18 and divide it by 9 if you want to. But this is what I say is, in order for me to get from 18, which is my 18 is here, my 18 is here, in order for me to get to 45, how many steps do I need to take? Or to get to -9, how many steps do I need to take? Which is, in this case, everybody see that 18 take away 9 to give me 9. If I take one more step, which is 9 take away 9, will give me 0. And if I take one more step, which is 0 take away 9, I will have -9. Or if you plug it in here, if you plug 18 minus 3 times sigma, you will see that you have -9 in this item. And if you plug it in here, they have to be symmetric. If you take 3 steps to the left, you have to take 3 steps to the right, which is everybody. If we take 3 steps to the left, 3 steps to the right, we can see that they are, the answer will be almost all of my data. Okay. One way is you can plug in your number to each of this location, and then you just look at your corresponding letter, corresponding number. Right? One way you can do is you can plug in all of your number, plug in the mu, plug in the sigma, subtract this item, you will get -9, you will get 0, you will get 9, you will get 18, you will get 27, 36, and 45. And then you just say, oh, -9 is here, 45 is here, so they will be almost all of my data. Is that making making sense? Well, let's take a look at one more example, and hopefully in the next example you will see a little bit easier if whoever's still puzzling. And after the next example, I will take any question if there's any question. So let's take a look at another example, which is similarly, I want to point out, ladies and gentlemen, what is the difference between X bar versus mu? Well, X bar is the sample mean, and reminder, the S is your sample standard deviation. Again, the information is the same. The only thing different is now, instead of we deal with population, we deal with a sample data, okay? So looking at this thing here, you can see that they basically very identical, right? They say that assume that the sample is a bell-shaped curve. That's a green light that we need to use your empirical rule. Between what two value is approximately 95% of your data. So looking at this thing here, let's go back to our empirical rule. So because it's a bell-shaped curve, we know that this is my bell-shaped curve. And looking at this item, they asked me between what two value is include 95%, which is, we know that in order to include 95%, it has to be this item to this item. My lower endpoint is over here. My upper endpoint is over here. And ladies and gentlemen, I know you say, wait a minute, this thing here is a mu. They don't give us the mu here. The mu and the X bar, they are interchangeable. It's basically tell you it's the mean. And sigma and the S, they are interchangeable. It just basically tell you that we are dealing with a sample data. Okay, so again, the sigma and the S is the same, which is you can just plug in your X bar minus 2 times S. And X bar plus 2 times S. But if you look at this thing here, this is how if I plug it in, which is 2 times S, which is my S is 17, my X bar is 153. 2 times 17 to give me 34, which is, I know my upper limit is 187. And if I plug in the lower limit will have 2 times 17 will give me -34, and 153 minus 34 will give me 119, which is between 119 and 187. Those will be include or cover all approximately 95% of my data. Okay. And the other way to look at this is what to make it a little bit easier to correspond to the steps and the unit. This is why I told you guys that the mean is in the middle. The mean is 153. And if I take one step to the right, I need to add the actual 17 unit. Again, for every step you take, you need to add this much unit, which is your standard deviation. So if I take one step, I need to add 17 to give me 170. And I know that in order to include almost 95%, I need to take 2 steps, which is if I take another step, I need to add 17. And if I take 170, add to 17, I get 187. Similarly, if I walk to the right, I add. If I walk to the left, I need to subtract, which is 153, subtract 17 to give me 136, and vice versa, 136 subtract 17 to give me 119. So doesn't matter how you do it, you can plug into the formula and see the value, and then ask yourself, well, between what two value is 95%, which is you see if you were to list every single number, which is this number, if you were to take one more step, which is this item will be 102, because 19 minus this will be 2, which is 102. And if you take one more step here, this will be 204. You add 17. So if you want to, you can list the whole 6 number, include the mean, which is 7 number, and then just ask yourself, well, 95%, what 2 number, which is this 2 number? If they say almost all, you say 102 and 204. I did not do that because the question didn't ask me, but I tell you that you can plug it in and find it out, right? And similarly for B, do you see that they ask us, assume that this item is a bell-shaped curve, approximately how many or what is the percentage of the sample or between 136 and 170? Well, we got this, right? We got this, ladies and gentlemen. 136 is right here. We got the number that we needed. 136 is here and 160 is here. So what is that item? You can see that between that two value is 68%. So that's one way you can do it, is you can just list every single number that you have, which is, that's the only thing about empirical rule is they only have that fixed 3 item. 1 standard deviation, within 1 standard deviation, 68%. Within 2 standard deviation, 95%, and within 3 standard deviation, almost all of your data. So in this case, this is my 2 answer, which is for A, this is 1 answer, and for B is 68%. So let me ask you guys, any question on how I derive to get my answer, or any question in general with this problem here? So everybody got this empirical rule and how to use the empirical rule to apply to your problem? I take that as a yes. So like I mentioned earlier, your goal, your most important thing is you have to identify when can you use your empirical rule. And to add a little bit salt to the wound, again, your bell shape, whenever they say bell shape, we use empirical rule. But if they don't say bell shape, what happens if we don't have a bell-shaped curve? What happens if my data is something like this, where it's not symmetric, not bell-shaped curve? Well, if it's not a bell-shaped curve, we have to use your Chebyshev inequality, which is, that is your 2 options. If your data say is a bell-shaped curve, we use empirical rule. We use what we did before, which is the 68, 95, and almost all. That is what we did prior to this item. But if your data is anything that is not bell-shaped curve, you have to use this Chebyshev inequality. And this Chebyshev inequality basically tell you that for any data that is not symmetric, we can estimate the percentage of the data that is covered by 1 minus 1 over k squared. And what is the k? The k is the within the standard deviation, meaning within 1 step, within 2 steps, or within 3 steps. Okay, so you will rarely see within 1 step because the Chebyshev inequality cannot calculate the 1 step. Why? Because if you look at this thing here, what is 1 square? Well, 1 times 1 is 1. What is 1 over 1? Well, 1 over 1 is 1. And 1 minus 1 will give you 0. Basically, the Chebyshev inequality tell you that if it's within one standard deviation, will be 0%. The reason is my data, we don't have a fixed number of data. Your data can be scattered like this, can be skewed to the left, can be skewed to the right. It can be anything. We are not sure of what your data is, so we cannot calculate within one standard deviation. The Chebyshev inequality most commonly calculate is the 2 standard deviation and the 3 standard deviation. Again, it can calculate anything else. Your K can be 1.5, your K can be 2.1, your K can be anything. It's just that to connect to our empirical rule, the K, if the K is 2, meaning if within 2 standard deviation, it will cover 75%. And how is that possible? Well, 2 times 2 is 4, which is 1 minus 1/4, right? If I have 1 minus 1/4, which is give me 3/4 of the item, which is 75%. Okay. And again, if we have K is equal to 3, K is equal to 3, which is 3 times 3 is 9. 1 over 9, which is 1 minus 1/9 is 8 over 9. 8 over 9 is roughly 88.9%. So this is the other item. If it's not a bell-shaped curve, then we cannot use empirical. We have to use Chebyshev. And the Chebyshev, just to be in short, the Chebyshev inequality just tell you that within 2 standard deviation, it will cover 75%. Within 3 standard deviation, it will cover 88.9%. And the only reason why we use 2 and 3 is those are the 2 common items we have. You can find any other item, but most of the item they will ask you is the 2 and the 3. Okay, so that is your objective. Is, you know, if you read, let's take a look at this problem here. If you look at this thing here, you say, well, they give me the same data, they give me the mean, and they give me the sample standard deviation. And yes, that is what they give you. Doesn't matter what the history behind this data, but if you look at this thing here, this is similar to number 2 when we deal with the empirical rule. But look at this item. Do you agree that when you read this thing here, this is what you need? Question?
Yes, go ahead. I'm an old woman, I ain't young like you. I can't jump.
Any question? So if you read this thing here, the first thing I want you to look at this is, ladies and gentlemen, when you read this, at least what % of the data of the sample value between 65 and 93? So looking at this thing here, do they mention anything about a bell-shaped curve or anything about bell-shaped or symmetric? Looking at this thing here, they don't mention anything about bell-shape, so we cannot use in your empirical rule. Your empirical rule strictly can only apply if you have a bell-shaped, symmetric bell-shaped curve. If they don't have a bell-shaped curve, we cannot use empirical rule. So since they don't mention anything about bell-shaped curve, we have to use the Chebyshev inequality. Everybody see that? So that's your 2 options here. Is you either use the empirical rule if they mention bell-shaped curve. If they don't mention bell-shaped curve, we have to use the Chebyshev inequality. So looking at this item here, one thing you can do is you can convert this to the z-score. We will do the z-score later in 3.3, but you can take this item and ask yourself, how many standard deviation are we? Which is, you can take your data minus the mean divided by the standard deviation. But we don't have to. If you look at this item, let's go with the same scenario that we have earlier. We know that the mean is 79. which is the mean is in the middle. And every time I take one step, I need to subtract. If I go to left, I need to subtract 7. If I go to the right, I need to add 7. So this is one way you can say is, how many steps do I need to take from 79 to get to 65, right? How many steps is that? How many units do I need to move from 79, go all the way down to 65? So if you look at this thing here, 79 minus 7, because if I take one step, everybody see that if I take one step, I need to minus 7. So 79 minus 7 to give me 72. That is not 65. I need to take one more step, which is 72 minus 7 to give me 65. I got the number I needed. So how many steps it took you from 79 to 65? Which is, in this case, we took 2 steps, which is my k is equal to 2. And if you remember the previous slide, if the k is equal to 2, that will include 75% of your data, or approximately, roughly 75% of your data. So the idea here is basically ask yourself, and a little bit, I show you the other way, but you can ask yourself, how many steps do I need to take? Each time I take one step, I need to subtract this number. So if you want to, that's what we can do, is we got that item. And vice versa, the other type of question, the other item is, instead of give you the value, they ask you what is the value if we want to include at least 88.9%. And if you remember the previous slide, 88.9%, what is your K that corresponding to 88.9? Well, your K for 88.9 is 3, right? So our corresponding 88.9%, the K is equal to 3, and we can plug into the same formula that we had before, which is to find the lower limit. We can say that the mean minus K times the standard deviation, which is, we can say that the K is 3, standard deviation is 7. I can take the lower limit, which is the mean minus 3 times 7, which is I take 3 steps, right? 79 minus 7, 79 minus 7, 79 minus 7, 3 times, which is, instead of doing that, I say 3 times 7 to give me 21. And to find the upper limit, I can take the same number, 79 added to 3 times 7 to give me 100. So in short, between 58 and 100, that will be cover at least 88.9% of my data. Okay. If you don't see this, let me sneak peek. Let me so one thing I mentioned earlier is if you don't see how I got the 2, one way you can do it, which is, this is what we will do on Thursday, is in order to find this number 2 right here, we can convert this into a z-score, which is the z-score basically tell you is the data minus the mean divided by the standard deviation. So if you want to, you can plug into this formula, which is, we will see this formula more on Thursday, but basically tell you that whatever your data is, which is in this case, you can see that your data is 65. If your data is 65, we can say that this is what we have is 65 minus 79 divided by the standard deviation is 7. So if you take this number 65 minus, if you take this number 65 minus 79, that will give you negative 14 divided by 7, which give you equal to negative 2. So basically, you can see that this negative 2 basically tell you that you need to take 2 steps below, right? And again, if you take the 93, you will see that it's equal to 2, which is, that is how my K is equal to 2, ladies and gentlemen, okay? You can take your data minus the mean, take the data minus the mean divided by the standard deviation. Your data minus the mean divided by the standard deviation, and that, whatever that number is, whatever this number is, that is your K. Okay, and again, the other one, this is just the same as your empirical rule, which is your mean subtract the 3 times the standard deviation, or your mean add the 3 times the standard deviation. Okay, so for part A, you can plug into this formula to find your K, and then if your K is 2, you say that's 75%. If your K is 3, then we say it's 88.9%. Okay. Vice versa, if you're 75%, our K is 2. If 88.9%, your K is 3. And those are the only 2 common K that they will ask you relate to the Chebyshev inequality. The data can change, but those are the 2 common K that they will ask you. Question with this thing here in terms of number 1, A or B. Question on how I got the answer. Question on how I got this answer 75 and how I have this answer 58 and 100. And again, if you don't have question, your challenge, like I mentioned, your challenge for this type of problem is make sure to know when you use in your empirical rule versus when you use the Chebyshev inequality rule. Like I mentioned, if your data, if your question, should not say data, if your question does not have anything related to bell shape, then again, if you look at this thing here, clearly they say that it's a bell shape. And if it's a bell shape, this is your empirical rule. If your data or your question does not mention anything about bell shape, meaning your data is not symmetric, and if it's not symmetric, we have to use your Chebyshev inequality. Okay. So question with this item here, well, if you don't have question, let's stop here